Hello everybody. So what we're going to be working on today is going to be Lecture 6, Infinite Limits and Trig Limits. So this is going to be a lot easier than the previous lecture. The previous lecture was, if you remember, working out limits analytically. It involved a lot of algebra. This section, thankfully, does not. You'll probably just want to have a scientific calculator handy. Uh, if not, you can use a computer. And even then, you don't even really need a computer. You can do it all by hand. So let's go ahead and get started. So what we're going to look at first is going to be infinite limits here. So infinite limits. All right. So the basic idea here is that some graphs, if you look at them, I'll draw a picture. Some graphs of functions, they do whatever. And then as you head out to the left or to the right, maybe the graph just keeps going up forever, right? So like you head out to the right and the actual function goes up forever. And if it goes up forever like that, increases without bound, we would say, then you might say that the function had a plus infinity for a limit. And if I go the other direction here, is that the right color? Yeah. You might say that if you head out this way, then the graph goes down forever. And so you might say that a limit is negative infinity out that way. Now, it's not just way out to the left and way out to the right where that happens. That's what I drew. But another way you could have an infinite limit would be a case where you have like an asymptote or something. So like, I'll draw a picture of that as well so you know what I'm talking about. So let's say that you have a function, and right here, like let's say that that's x equals 3 or something. And you have a curve on this set of axes. Does that. And maybe in the other direction, it goes like this. Oops. Hard to draw a straight line. There we go. Okay. So maybe this is like y equals f of x. Then what you would say is that if you have a limit on this graph as x goes to 3, you have to pick a side, left or right. I'm going to pick right, of f of x. Like, what would it be? Well, we know how to get limits from graphs, right? If you're on the graph and you're heading towards 3 from the right, then you trace the curve this way, and you can see that the graph is going to go down forever. Well, down forever like that is towards negative infinity. So this limit is what we would call negative infinity. And similarly, if you do the limit as x approaches 3 from the left-hand side, so you're over here on the left-hand side of the graph, and you approach 3, it goes up forever. And if it goes up forever like that, then we would say that that limit is positive infinity. So that's what it looks like on a graph. Goes up forever, like infinitely high on the y-axis is plus infinity, and infinitely low on the y-axis is minus infinity. Now you can also do this from a table of values as well. So let's look at a table. Table of values. How would we do it? So suppose we want this limit. Suppose we want to compute a certain limit. This one. Limit as x goes to 2 from the right-hand side of 1 over x minus 2. Okay? Now, think about how to evaluate this based on what you know right now. So if you were going to try to evaluate this with what you know now, you would probably try to plug the 2 in for the x. Okay? So you try plugging in 2. When you do that, you're going to get 1 over 2 minus 2 which is 1 over 0, right? Well, any time that you get a constant over 0, that's going to tell you from now on that your limit is going to be plus or minus infinity. Okay, that's a clue. It's not a clue, it actually just tells you that's going to be plus or minus infinity. So whenever you get a constant over 0, a non-zero constant, I should say, 0 over 0 could be anything. But 1 over 0 or 2 over 0, negative 10 over 0, that's always going to be some kind of infinity plus or minus infinity. Okay, any constant, non-zero, constant over 0 is going to give you plus or minus infinity. Plus infinity or minus infinity for a limit. Okay, now I'm just telling you that you don't need to think too hard about it right now, because what we were going to do is we're going to try to look at it, coming at it from the direction of a table of values. Okay, so even if you didn't know that it was infinity, we're about to figure that out. Okay, and so if you're trying to find that limit using a table of values, then you would make a table. We're going to have our x values, and then we're going to have our 1 over x minus 2 values. Right, that's the function. And we're approaching 2 from the right-hand side. So if you're to the right-hand side of 2, right, on a number line 2 is here, then you have like 2.2, so on. I don't know why I put it 2.2, could be 2 point anything. But 2 point something is on the right-hand side of 2. So if you want to approach 2, you can go 2.1, 2.01, 2.001, 2.0001, right? Those are getting closer and closer to 2. And then you take those numbers and you plug them into your function here, and you see what you get. Now, when you do that, probably going to want a calculator. So when you do that, I'm going to get, I'll do one of these here. So if you put like a 2.1 in, it's going to be 1 over 2.1 minus 2, which is 1 over 0.1. 1 enter 0.1 divide. What? Why is my computer not working? Okay, so when you work this one out, you're going to get 10. And then so you work out this one, you're going to plug 2.01 into this function here. Oops. What? You get 100. Plug this one in, you get 1,000. You plug 2.001 in, 0001 in, and you get 10,000, right? And so you look at those values and you should be able to guess that if this keeps going to 2, what is this going to be doing? Well, 10, 100,000, 10,000, it's clear that these numbers are just getting bigger and bigger and bigger forever. So that should be plus infinity. Okay? So hopefully that makes some kind of sense. So if you're evaluating a limit that way, you can, you can evaluate a limit that way using a table of values. Okay? Now, once you have that idea, again, I'm going to say that you should recognize a 0 over 0 as giving you some kind of infinite limit. I just said 0 over 0, but I meant constant over 0. If you have a constant over 0, it's some kind of infinity. Okay. Now, let's look at that maybe in a more complicated situation here. Hold on a second. All right. So let's say you have something like this. Let's say you have example. Evaluate the limit as x goes to, I don't know, let's say 3 from the left-hand side. And let's say we have x minus 3 cubed over, let's just go x. Okay, you're trying to evaluate this. So here's how you would go about it. You would say, okay, first thing, try to plug in x equals 3. You try to plug in x equals 3, you're going to get 3 over 3 minus 3 to the 3, which is 3 over 0. Okay, now when you get the 3 over 0, that is telling you that you have some kind of infinity here. Okay, some kind of infinity. So you say, so it's plus infinity or minus infinity. Technically, it could also not exist, so I'm going to say or doesn't exist. And we'll see an example of that momentarily. So it's plus infinity, it's minus infinity, or it doesn't exist. Okay. Now, once you know that, really kind of, if it's a one-sided limit, then this is not a possibility, actually. So it's a one-sided limit, then this won't be an issue. It will exist. Okay, so if it's a one-sided limit, it will exist, but if it's a two-sided limit, then maybe it doesn't exist. So this is a limit from the left. That's what the minus here indicates. So it does exist. All right, so if it's a one-sided limit, it will exist. We know it's plus infinity or it's minus infinity. So the only question is, which is it? Since we know it's plus infinity or minus infinity, the only question is it plus or minus? The only thing we have left to find is whether it's plus or minus, right? Because it's either plus or minus infinity, we just don't know plus or minus. So the easiest way to do it, and this is how I'm going to recommend that you do it, is just pick a number, right? X is approaching 3 from the left. So just pick a number close to 3 on the left, and we're going to plug that number into the function and just see if it's positive or negative. That's all we need to do. So just choose a number to plug in into the function to see if it's positive or negative. Now, the homework might tell you like more complicated ways to do this, but this is going to be the easiest way. So again, the limit that we were solving was the limit as x goes to 3 from the left of x over x minus 3 cubed. Right? So you want a number close to 3 on the left, right? Because we're doing a limit from the left. So what's to the left of 3? I don't know, like maybe 2.9. That's going to be fine. Maybe use x equals 2.9. That'll be perfectly fine. So plug that in into the function. Plug that in you get 2.9 over 2.9 minus 3 to the 3, which is 2.9 over, looks like negative 0.1 to the 3, which is something. Let's find out. Enter, enter, enter. So that's 2.9 over negative 0.001. And so that is negative 2,900. Okay? So with that in mind, you see that it's negative, right? So since that's negative, we conclude that the limit as x goes to 3 from the left-hand side of x over x minus 3 to the 3 is minus infinity. Okay, so there's two steps there, right? We plugged in 3, we got 3 over 0. That told me it was plus or minus infinity. I needed to know which, so you pick a number just on the left-hand side to plug in, and it should be close to where you're taking the limit of, right? So if we're going to 3, it needs to be close to 3. So we plugged in 2.9 because it's close to 3 on the left, and we get a number, and all you care about was whether it was plus or minus. Okay? We see the minus sign. That's it. Okay? Basically what we're doing is, if you go back to where the table is, right? So when we did this problem with the table, and we plugged in 2.1, 2.01, 2.001, 2.0001, think about this. If you already knew that it was either plus infinity or minus infinity, then would you need all those numbers in the table to tell you whether it was plus or minus? You wouldn't, right? Like, if you were doing this previous problem that we did with the table, and I knew just from this right here that it was going to be plus or minus infinity, and then I skipped the table and I only did this one from the table, right? So just forget the other terms in the table. All I did was plug in 2.001 and I got 1,000. Well, 1,000 is positive, so I would have been able to conclude plus infinity just from that. I don't need to see the whole table, right? So that's what we did here. We only plugged in one number from the table, and that was enough because we already knew it was plus infinity or minus infinity. All right. So those are infinite limits. Again, you're looking for constant over 0. That's going to be your clue. Okay. Let me get a question here. All right. Now let's look at trig limits, which we're going to see infinite limits here too. So don't stress about not doing enough work yet for infinite limits. We're going to see infinite limits. So trig limits. So the first kind of trig limit that you might do is just going to be one where the function is continuous. So if you're lucky, the limit will be somewhere, I'll just say somewhere, where the function is continuous. If that happens, you can just plug in the value. And I'll show you that in 1 second. Example. If I have to do the limit as x goes to pi of cosine x over 2 plus cosine x over 3, there's no issues with plugging a pi into that function, right? We're taking the limit as x goes to pi, and there's an x and there's an x. Well, just try to plug in pi, right? Just plug in pi. You get cosine pi over 2 plus cosine pi over 3, which if you evaluate those functions using the unit circle, I'm going to put a link up to a unit circle on the website, then you should just be able to get these numbers here. So what's the cosine of pi over 2? So the cosine of pi over 2 happens to be 0. And then you have the cosine of pi over 3, which happens to be 1/2. So you add those together, and you get 1/2, and that's your answer. Okay, so that's the case if you're lucky, right? If you're lucky, you can just plug in the value. And you always know that the way that you try to start out a limit anyway is you always at least try to plug in the value. So if you plug in the value and you get a number, good for you, you're done. So that's going to be your first case. Now, what if the function's not defined? If the function's not defined, then you're going to have to do something else. So if the function is not defined at the point, then you're going to have probably an infinity or something, but you're going to have to figure out what it is. Then either it's plus or minus infinity like we just saw for the infinite limits, or possibly it's a limit that you're supposed to know, and I'm going to show you which ones you're supposed to know. So a limit you should memorize, or it's related to a limit that you should memorize. All right, so I guess let's see the case where it's like infinity or minus infinity or something like that. Example. Evaluate. Limit as x goes to, well, let's not make this too complicated here. Pi over 2 from what side? I'm going to go from the right of tangent, just x. Okay, so how would you start this? Right, hopefully you start these all the same way. You try to plug in the limit. So try to plug in pi over 2. So you get tangent pi over 2. Okay, so I have a calculator. I'm going to punch that in. Actually, I guess I'm going to use, let's use this calculator just to see. So if I go tangent pi over 2, I don't know where pi is on this calculator. Oh, there it is. Pi over 2 parentheses, enter. I'm in degree mode from yesterday. Try again. Radian mode. Pi over 2. Very important. Make sure you are in radian mode on your calculator for all of these. So tangent pi over 2. Math error. Okay, that's not defined. Okay, tangent pi over 2 is not defined. So if I go to like Wolfram alpha and I say tan pi over 2, nope, interpreted it the wrong way. Try that. What's it say? That's a weird something infinity. I don't know what it's saying there. Okay, it's not a regular infinity. So that's you know, that's not what you want. Okay, that's not a number that you can write as an answer here. We try to plug that in there. It is undefined. Right? We got a math error. Undefined. Now that does not mean that the limit doesn't exist, because this is a one-sided limit, and so it might be infinity or something. Okay, so what we do need is we need a value close to pi over 2 on the left or the right to see if it's plus or minus infinity. But the limit, so let's write this. But the limit may be plus infinity or minus infinity. To check, we need to plug in a number close to pi over 2 on what side? So it says pi over 2 plus, so we're on the right-hand side, close to pi over 2 on the right. Okay? So in order to do that, we need to know how big pi over 2 is, right? So what I'm going to do is I'm going to grab a calculator, and I'm just going to type pi over 2. I'm going to use my calculator instead of the one on the iPad, because then I have to switch back and forth here. So let me find a pi. Okay, there's pi. Enter. 2, divide. It says pi over 2. How do I make you give me a number here? Oh, that's terrible. All right. Well, I don't know how to do that, so I guess I lied. We're going back to the other calculator. Right later. All right. Pi over 2, enter. So 1.570796. 570796. Nope. Nope. 570796. 579706. 579706, really? Okay, let's see. 570796. 0796. 0796. Oh, 796. Okay, sorry. All right, so what are we going to plug in? How about 1.58, right? That's going to be bigger. So let's try 1.58. Why 1.58? Because if pi over 2 is here, 1.58 is on the right. Okay, so tangent x. So what's tangent 1.58? Okay, so we're going to grab a calculator. Guess we might as well use this one again. Tangent 1.58. Enter. Negative 108.65. Negative 108.65. Right? So, just from this right here, if you're evaluating the limit as x goes to pi over 2 of tangent x from the right, well, what do you think it is? We only checked one value, but negative 108.65, what do you think? How about that? Okay. Now, if you think that that's not, like if you're not convinced just from this right here that the limit is going to be negative infinity, you could check more values, right? You could check tangent of, how about 1.571? Isn't that also to the right? of 1.570796? It is, and it's a lot closer to pi over 2. So let's try that, 1.571. Let's try that. Negative 4,909. 4909. Okay, so hopefully between those two values, you agree that limit of tangent x as x goes to pi over 2 plus is negative infinity. Okay, so what have we done here? What we've done is, if you've got a nice continuous function, sine or cosine, or any of the trig functions, if you can plug in the number and get a number, then that's fine. Just plug in the number and get a number. If you plug in a number and it's not defined, then you need to check if it's plus or minus infinity the way that we just did. Okay. Now, what limits are you supposed to just know? Two of them. Two limits you're supposed to know. All right. So what are they? So the two that you're supposed to know, one of them is this one. The limit as x goes to 0 of sine x over x is 1. We'll see why. The other one, I'm going to write it. I just want to, yeah, here's the other one. Limit as x goes to 0 of, I want to see this actually. Continue. No. Come on now. Killing me here.
Next we have.
Nope, stop talking, computer. Stop talking, computer.
It looks very similar.
I can't make my computer stop talking to me. All right. Forget it. I will find it when we use it. Let's do the first one first. I'm going to write it up here when we find it. But here is what I want. So limit as x goes to 0 of sine x over x equals 1. If you're evaluating this one here, come on. You're evaluating this limit right here. You would have to do it with a table. There's not another way. So you would make an x. You would have sine x over x. And your x is going to 0, so you'd go like 0.1, 0.01, 0.001. Then you'd have to do the same thing from the negative side, so negative 0.1, negative 0.01, negative 0.001, something like that. Okay, and if you evaluate these, sine x over x and so on, calculator. So we got sine 0.1 divided by 0.1. What do we get? 998. $9,983. Change this to 01 and this to 01. 99998. So 4 nines. I'll save you the trouble. This is going to be 1, 2, 3, 4, 5, 6, and then an 8, right? Hopefully you can see that those are very close to 1. You have to do this from the negative side as well. So you plug in negative 0.1. So go back here. Put a minus there. Put a minus there. Same number. The minuses don't mean anything. They don't matter for this one. So this is 0.9983. You can check the others, but they're 99998 and 1, 2, 3, 4, 5, 6, 8. Right? So you look at this table, and that table is what tells you that this limit is going to be 1. Right? Because you see these just getting closer to 1 as you go. Okay? Gonna just fix my speed issues here. Come on. I don't know why I have to do that after I switch tabs too much. Okay, so that's getting closer and closer to 1. Okay, and I still haven't yet to write the other one that you're supposed to know here, but we'll come back and do that. Okay, so that is 1. Now, how are you going to use that? Well, they make you go through a bunch of algebra that's kind of annoying, to be honest, but they just want you to get used to solving problems. So if I say this, if I say find the limit as x goes to 0 of, and I'm going to say sine 7x over 3x, okay, that limit is not 1. Okay, the 7 and the 3 there actually have an effect. Okay, the 7 and the 3 actually have an effect. Matter here. So you can't just say it's 1. Answer not 1. Okay, so you've got to do a little bit of algebra. So how you do the algebra is up to you. There are shortcuts which you may be tempted to employ. Here's how I would do it. Okay, if you've got a 7 in the numerator, then you need to match it in the denominator. So you want to somehow match the 7 in the sign with a 7 in the denominator. Now, how are you going to get a 7 in the denominator? Well, you're going to have to add 1 because there's not one there, right? So you want to add a 7 in the denominator that's not there, okay? But you can't just add a 7 in the denominator and not do anything to the numerator because you'd be changing the problem. So if you add a 7 to the denominator, you have to add a 7 to the numerator. So I'm just going to multiply by 7 over 7. Now, why would I do that? What's that get me? Well, if you rearrange this a little bit, what you can do is you can write this as sine 7x over 7x times, so I just moved the 7 over to where the 3 is, and I guess I'll move the 3 over to where the 7 was. So you have this, right? So all I did was, in the denominator, I just switched this and this, basically. And you can do that because 3 and x and 7 are all multiplied. So write them in whatever order you want. Okay? Now, how does that help me finish this limit? Well, it helps you finish the limit because due to the rules of limits now, you can take the 7/3, which is just a fraction, out of the limit. That was a property of limits. And then you just have sine 7x over 7x. Well, if this number and this number match, then the limit will be 1. If the 7s match here, then this is going to be just the same as this original limit here. And why is that the case? I'll show you. I'll show you why that's the case. The reason that that works is because if you just made up a new variable, make up a new variable. Let's call it y, and it's equal to 7x. Okay, so basically if you just replace your 7x's with y, then you would get 7/3 limit as y goes to 0. I'll say something about that momentarily. Sine y over y. Now, the reason I can just say y equals 0 here, or y goes to 0 here, is because x was going to 0. But if x goes to 0, wouldn't y also have to go to 0? Because y is 7x, and 7 times 0 is 0. So you can just replace all of the y, or all of the 7x's with y's, and you get this. But then what is this limit right here? That's the same as the one that you memorize as 1. Right? It doesn't matter if it's a y or an x or an a or a b or whatever. Whatever this is, as long as they match, then the result's going to be 1. Okay? So you come back here. The part that I underlined here is 1, so you just have 7/3 times 1, which is 7/3. And that would be your limit. Now, I know that because this was the first one that we were doing, that there was a kind of, that was hard to understand. Let's just try a different one, and I think you'll see that it's not as hard as I just made it sound. Let's go sine 5x over 2x. Right. So how would you actually do this? You'd say you would add, right? We're adding. We want to match the 5x. So you just go 5 over 5. Rearrange this as sine 5x over 5x, and then you have a 5 and a 2. Just replace just switch around the 5 and the 2 in the denominator. And then when you do the limit, you can just do that limit right there and just say that that's 1, and then you have the 5 over 2. You don't have to rewrite it as many times as I did previously. And so that would be 5 over 2. All right. What if you're too lazy to do that? Okay, so this would be the super lazy way. If x goes to 0, then sine x is approximately x. Why is that? Well, think about it. Look at the limit that you're memorizing right here. Sine x over x. How do you divide two numbers and get 1? Like, what kind of things do you divide and get 1? Like 5 over 5, that's 1, right? 6 over 6, that's 1. 100 over 100, that's 1, right? If you divide two things and you get 1, doesn't that mean that they're basically the same thing? Like the top and the bottom of the fraction must be the same? It does in some sense, right? So if x goes to 0, then sine x and x are basically the same thing. And so if you ever have to evaluate the limit as x goes to 0 of, let's just say, let's do the same one, sine 5x over x, what is it, 2x? What was it? 2x. What you could do is just say, well, that should be the same limit as, well, if sine x is approximately x, then sine 5x, shouldn't that be approximately 5x? It should. So you can just replace the top with 5x, and then you just have 5x over 2x, which is 5/2. Right? And that seems so easy that it feels like you're cheating when you do it. You're not actually cheating. That is mathematically justified. if you knew more calculus than you know right now, then what you'd be able to say is that we just replaced sine 5x with its first degree Taylor polynomial to help us evaluate that limit. Okay? It is a mathematically valid way to do the problem. Right? And this is left side there is sine x, that's a function. Right side is a polynomial approximation of the function. And it is valid. You're allowed to do it that way. Okay? But there's no way that your book is going to teach you that one because they don't want you to do it that easily, to be honest. All right? Let's scroll up. Let's look at the other limit that I said you need to know. So the other limit that you need to know is this one. 1 minus cosine x over x. And what is that one? That one is 0. Okay? That one is 0. So, yeah. How would you do it? You would do it the same as you did the same as what you would do for the sine ones. So like if you have, here's one straight from the homework, limit as x goes to 0, 1 minus 5x over, 1 minus cosine 5x over 10x, like that. That's not the one that you just memorized. That's related to it, right? You need a 5x on top and bottom. So you can do the same trick that we did before. 5, 5. You can put the 5x there. Then you have the 5 on top left. You move the 10 over there. Then you have limit as x goes to 0 of 1 minus cosine 5x over 5x. And this 5 over 10, you can write over here as a 1/2. All right. So what is this limit that you're supposed to know? Well, it's up here. 0, right? You're memorizing that that one is 0. And just like for sines, in order for that to work, it needs to be 5x, 5x. They need to match. All right, so that's 0. So it's 1/2 times 0, which is 0. Okay? So the techniques that work on that limit are exactly the same. Now, you might be thinking, well, what about the super lazy way? Can we do it the super lazy way for the cosine version? And the answer is yes, we can. So what's the super lazy way here? So the super lazy way is as x goes to 0, cosine x is approximately 1. And you know that, right? Like what's cosine of 0? It's 1, right? So that's the approximation. So if you had to evaluate the same limit here, let's do the same one. Limit as x goes to 0 of 1 minus cosine 5x over 10x, right? Now, the limits are equal here. The functions are not equal, right? So if I didn't write the limit, then this would not be a valid equality. But because they're limits, you can do this. So what do we say? We say that the cosine is approximately 1. So this is basically 1 minus 1 over 10x, which is the limit as x goes to 0 of 0 over 10x, which is 0, right? Because the top is 0. So it's 0 before you get to the point of plugging in 0. So it's 0, right? Now, again, the way the book is going to solve this is going to be more convoluted than what I just did. So you're going to want to either do a little bit of algebra like I did, or you want to do it the super cheaty way, where we just replace the function. Again, it is mathematically valid. So I'm just double checking that there's nothing in the homework that we haven't seen. And there is not. So I think that's good. Okay, so we're going to stop here. And good luck with the homework. I recommend the super lazy way, but you're on your own. For that, yeah, see you next time.